Mathematics of image formation by curved mirrors. Here you can see a concave mirror with an object standing in front of it beyond the center, forming the image below the axis. Let's draw in an additional ray that goes from the object towards the mirror and then reflects off at the same angle below the axis. So here we want to make two triangles. Let's look at the triangle here from the object above the axis, and we'll make this triangle green right here. So let's fill that on in there. Alright, so we have one triangle that's going to be above this axis. And let's make the triangle below the axis that the image makes down here in purple. So let's go ahead and make that our purple triangle below. Now, as you might start to see, these two triangles are actually similar triangles, meaning they both have 90-degree angles here, and they also both have these two angles that are also equal by the law of reflection. And thus the angle of incident and reflection are equal. So since they're similar, we can also see that the object height here is in the same ratio to the image height as the distance of the object is, remember that's DO there, as the distance of the image is. So these ratios of heights and distances are also the same. So we can come up with our first equation saying the image height divided by the object height equals negative the image distance divided by the object distance. Or, as I like to say, hi-ho equals negative dido. Let's look at our image formed by a concave mirror again. Let's look at the horizontal distances. We know the distance from the mirror to the focus is called the focal length, or f. We also then know that the distance to the object here is dO, and the distance to the image from the mirror is di. Well, if we go back to those similar triangles again, we can do a similar triangle proof that would then also show that 1 over the distance to the object plus 1 over the distance to the image equals 1 over the focal length. Again, this would be proven using the similar triangles proof. Here we'll just say that all the horizontal distances along the principal axis, DO, DI, and F, are all related by their inverses. Happy problem solving.